Hello, dear aspirant. This is Dr. Sourav Sir's class. We are solving the UGC NET, UGC CSIR NET 2024 June questions. So this question is from that paper, and the question is about linear algebra. So the question says that let A be a matrix, 4 cross 4 matrix, that is my 0 1 0 0 1 0 0 0 0 0 1 1 and 0 0 1 1. Okay, and consider the symmetric bilinear form on R to the power 4 given by this. The inner product of V and W will be my V transpose AW for my V comma W belongs to R to the power 4. So now which of the following statement is true? Okay. So this is my part B question. So it has only so it is single correct question. Okay. So now, so let us take the matrix A, and I am going to take it in our 4 block diagonals. So let us name, so let us mark it as this. So where our A is what, that is my this, and our B will be 1 1 1 1. Okay. So the eigenvalues of, no, let it write, let it be C, as our A is given earlier here. So let it be C. Okay. So now, so our eigenvalues of A are what? They are the eigenvalues of C and eigenvalues of B that will be for lie in our diagonals. Okay. So now we have to find the eigenvalues of C. What are they? I think we all know that, but let me try with your approach. So I can see that the row sum of both are my same. So one is an eigenvalue of C, and so my trace of C is equals to 0. So as we know that trace is the sum of the eigenvalues. So my given eigenvalue is 1, and let lambda be another eigenvalue of C. Yeah. So let me leave the screen. Okay. So our lambda will be what? Lambda plus 1 is my 0. So we will get lambda as our minus 1. So minus 1 and 1 are the eigenvalues of my C. Now we have to find the eigenvalues of B. So what can we do? That we again check that our row sums are 2. So 2 is an eigenvalue of my B again. So the same phenomenon will be happen here, as our trace of B is now my, yeah, sorry, I am wrong. So trace of B is my 2. So this is my 2 plus lambda B. Let lambda be the another eigenvalue of B. So our lambda B will be 0, as 2 and 2 will be cancelled out. So our lambda B will be my 0. Okay. So the eigenvalues of B are what? The 0 or 2 are my eigenvalues of B. So what are the eigenvalues of A? So the eigenvalues of the given matrix are my, so 0, 2, minus 1 and 1. These 4 are my eigenvalues of A. So as 0 is an eigenvalue of A, so A cannot be invertible. So our option A is cancelled out. And every eigenvalue of A square is positive, that will also be cancelled out, which is our option D, because we have 0 as an eigenvalue of A. So A square, so every eigenvalue of A square is positive is a wrong statement here. So now we have to think for our B and C. Let us think for B first. So the B says that there exist non-zero vectors V and W such that inner product of V and W is my 0. So what can be done for this? Let me write the matrix now. So what is my V transpose AW? So let us take VB, my V can be take V can be taken as my V1, V2, V3, V4 on a column. So I am writing here as this transpose. Okay. So my W will be what? W will be W1, W2, W3, W4, and there will be transpose. Okay. So these are columns. So we can write this matrix multiplication form that our V1, V2, there is V3 and V4. Yeah, I want to write V3. Okay. So now we will write the matrix. Given matrix is my this 0. I think this is my 1 0 0 1 0 0 0 0 0 1 1 and 0 0 1 1. Then we will write my W, which is my on the this, yeah, W1, W2, W3, W4. Okay. So we have to do the matrix multiplication now first. So we firstly taking these two. Then we will get what? We will get my V2, V1. After that we will get V3 plus V4. Then again we will get V3 plus V4. Yeah. V2, and that will be my V1. V2, there we will get V2, and for this we will get V1 and this. Oh, okay. So now we will get, yeah, that is 3. Yeah, 3 and 4. Okay. So that will be what? V2 W1 plus V1 W2 plus my V3 plus V4 into my W3 plus W4. So now we can get another thing from that. What can we get? That we have to think about a vector. So that they told us that VW, the inner product of VW will be 0. There exists non-zero vector. Okay. So we have to find a non-zero vector vectors V and W such that the inner product is by 0. So now if we take my W1B minus V1 and our W2B V2 and our W3B minus W4 or my V3B minus V4. Then what will happen? These two, for this thing, these two will give us 0 and either this or this. Both the in for both the cases, this will give us 0. So we got a non-zero vector. We can form a non-zero vector where when our inner product will be 0. So our option B is the correct one. So our option B is the correct one. Eventually my option C is cancelled out as this is a single correct question. Hope you understood. Thank you guys. Thank you.